Alright, today we're going to discuss how to graph rotations in the coordinate plane. This is part of the geometry unit, and our color for that is pink. A rotation of a geometric figure is a clockwise or counterclockwise turn of the figure around a fixed point. So to determine if something is clockwise or counterclockwise, you think of a clock. If the turn is in the direction that the arrows on the clock turn, then that would be the clockwise direction. So we're turning here to the left. A counterclockwise turn, so if your shape is going in the direction opposite the way the hands on a clock move, that would be counterclockwise, or a turn towards the, actually this one's towards the left and this one is around towards the right. Okay, two ways to graph rotations. The first way is kind of using pictures, and the second way is more algebraic with some rules. Okay, how do I rotate? So step one would be to always determine which quadrant your image will end in. That's your prediction. It's always a good idea to make a prediction before you start. Copy the image on a separate sheet of paper. Graph paper is the best. If you don't have graph paper at your house, what you can do is go to Google and type in graph paper PDF, and it'll bring up a list of several choices, and you can print off a sheet of free graph paper that way. Then we're physically going to perform the rotation. So we're copying the image, we're physically going to rotate the paper, and then we're going to write the coordinates of the image and graph. The other way that you can perform a rotation, first step's the same, determine which quadrant your image will end in. So where is your final picture going to be when you're done? Write the coordinates of the pre-image, so write the coordinates of the shapes that you already have, and then apply one of these three rules. For a 180-degree rotation, you're going to take the opposite of both coordinates, so you're going to make x and y opposite. For a 90 degrees clockwise rotation, you take the opposite of just the x, and then you switch the order of the coordinates. For a 90 degrees counterclockwise, you take the opposite of just the y, and then you switch the order of the coordinates, and then you'll graph the image. I'm going to show you both ways, so if you notice example 1 here and example 1 here, example 2, example 2, example 3, and example 3, they're all the same. So we are going to be doing each example twice. We're going to start by physically rotating the paper, and then we're going to go back through and I'll show you how to apply the different rules. Alright, so for example number 1, we have a trapezoid, and that trapezoid is EZCT. So for our free image, this is before we do any sort of transformation with it, in our pre-image, so it's kind of a good idea to write down your coordinates so you know where you're starting. Okay, I have E, Z, C, and T. Right. E is at the point 1, negative 1. Z is at the point 1, negative 1, 2, 3, 4. C is at the point 1, 2, 3, 4, negative 1, 2, 3. And point T is at the point 4, negative 2. Okay? I'm then going to copy that picture using those coordinates onto a separate sheet of graph paper. So my point E is at 1, negative 1. Z is at 1, negative 4. My point C is at 4, negative 3. And my point T is at 4, negative 2. Oops. Okay. Connect all your points together. So again, you're looking at your same trapezoid, but it's just copied on a separate sheet of paper. And then we're going to do a 180-degree turn. So we want to predict where that shape is going to end up. So if I think about 180 degrees, each quadrant is a 90-degree turn. So 180 degrees would be 2 quadrants. So I'm going 180 degrees, I'm rotating it 1, 2 quadrants. So I'm thinking my shape should end up in the 3rd quadrant. So back on your page of notes, our prediction, we think it's going to end up here. And I like to put a little check mark or some way to notate where I think my shape should end up when I'm done. So again, I'm going to take my copied shape. I'm physically rotating my paper 1 90-degree turn, 2 90-degree turns, which makes my shape end here. Okay. So then my next step would be to write down my new coordinates. Let's see if I can get it all on the screen here. I need to zoom out. There we go. So I'm going to literally read the coordinates off of this picture, and these are the coordinates of my image. All right, E is now at the point -1, 1. So E prime is at -1, 1. T prime, D prime is next. That's at -1, 1, 2, 3, 4. C prime is at the point -1, 2, 3, 4. 1, 2, 3. And T prime is at the point 1, 2, 3, 4, 1, 2. So -4, 2. And I made a mistake here. C is at the point, my original C is at the point, oh no, 4, -3. This one should be 4, 3. Positive Y. Okay? Then I want to take these coordinate points and I'm going to plot my shape. So I have -1, 1. -1, 4, -4, 3, and -4, 2. Connect my points together, and there's my new shape. Right, I'm going to change colors here to do the second example, so it's a little bit easier and they don't get too confused. So for example number 2, I'm going to start by writing down the coordinates of my pre-image. I have a triangle this time. Okay. Coordinates of my pre-image are C, R, and Q. So C is at the point -5, 5. R is at the point -2, 3. And Q is at the point -5, 1. I'm going 90 degrees clockwise. That's one quadrant in the clockwise direction, so one quadrant this way. So I'm thinking that my shape is going to end up here in quadrant 1. Okay? So then I'm going to, again, copy my shape onto a separate sheet of graph paper. So -5, 5. That's the point C. R is at -2, 3. And Q is at -5, 1. Connect them together, same triangle, and I'm literally going to turn my paper 90 degrees in the clockwise direction. And then I'm going to write down my new coordinates. So we're starting with C prime. C prime is at the point -5, 1, 2, 3, 4, 5. Sorry, 5, 5, positive direction. 5, 5. R prime, so my new R coordinate is at 1, 2, 3, 1, 2. And my Q coordinate is at 1, 5. Okay. Last example, we're going to do a 90 degrees counterclockwise rotation about the origin. And again, I have a little triangle here. So I'm going to write the coordinates for my pre-image. Read those off of the graph. I have X, B, and Z. So X is at the point 1, 2, 3, 1, 2, 3. B is at the point 4, 1, 2, 3. And Z is at the point 4, 1. Okay, I'm doing a 90 degrees counterclockwise, so I'm going to be rotating in this direction, the opposite way the hands on the clock go. So I'm thinking that my shape is going to end up over here in quadrant 3. We'll put a little mark there, just so we know that's where our shape probably should end up. Okay. Focus this a little bit. Got a little blurry for you. There we go. All right, so start again. We're going to copy our shape on a separate sheet of graph paper. 3, 3. 1, 2, 3. 1, 2, 3. And that's X. B is at 4, 3. It should be here. There's my X label over there. And Z is at 4, 1, right here. Okay, little triangle. And then I'm physically going to turn my paper 90 degrees in the counterclockwise direction, so I'm going to rotate my paper. And then I'm going to read off the coordinates of the image. So if I look here, I've got X prime, B prime, and Z prime after the transformation. So X prime is at the point -3, 3. B prime is at the point -3, 4. And Z prime is at the point -1, 4. Use those coordinates and plot them back on my original paper. So X is at -3, 3. -3, -1, -2, -3, 1, 2, 3. B prime is at -3, 4, right there. And C prime is at -1, 4. Oops. Not very good at plotting points, apparently. One more time. Always helps to pay attention to details. So X prime is at -3, 3. So -1, 2, 3, 1, 2, 3. Right there. B prime is at -3, 4, which is right here. That's where my mistake was. And Z prime is at -1, 4, which is right there. There's my triangle. It's been rotated 90 degrees counterclockwise, and it ended in the quadrant 3, which is what I predicted. All right, we're going to go back and we're going to do the same 3 examples, but this time we're just going to use the algebra rules. You'll see that this process is a little bit faster, but I know sometimes it's difficult to memorize all these rules and keep them straight. Okay? So coordinates of the pre-image. First thing we do is we write down still the coordinates of the pre-image. You can just copy those from above because they're exactly the same. So E is going to be at the point 1, -1. Z is at the point 1, -4. C is at the point 4, -3. And T is at the point 4, -2. Okay? So the rule for a 180-degree rotation about the origin is that we take the opposite of both coordinates. Okay? So E prime, I would take the opposite of 1, which is -1. Take the opposite of -1, which is +1. For Z prime, take the opposite of 1, which is -1, and the opposite of -4, +4. For C prime, the opposite of +4 is -4, and the opposite of -3 is +3. For T prime, the opposite of 4 is -4, and the opposite of -2 is +2. So if I look at this shape here, I'm doing 180 degrees about the origin, so I'm going to go 2 spaces, 2 quadrants. My prediction says it's going to be here, and then I'll plot these points to make sure that I'm correct. So E prime is at -1, 1. Z prime is at -1, 4. C prime is at -4, 3. And T prime is at -4, 2. And if I compare this drawing to the one above it, you'll notice it's exactly the same coordinates, exactly the same picture. A couple things to remember here. If your picture here looks different than your picture here, other than the fact it's in a different spot, you did something wrong. These shapes should be identical, just turned around a little bit. They should be congruent figures. Also, if you notice here, the image coordinates, my prediction was that this was going to end in quadrant 3. We know in quadrant 3, X is negative and Y is positive. So I can double check my coordinates here, negative, 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 positive, 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 positive. That works out. Okay, so that's kind of a self-check. The third thing is if you have a multiple choice question, you really don't have to do a lot of this work because what you can do is you can look to see which of the multiple choice answers has a negative and then a positive with it. So that way you can eliminate possibly 1 or 2, maybe even all of the other answer choices except for the correct one. All right, example number 2. Before we move on, we're going to go ahead and write the rule here. Take opposite of both coordinates. All right, example number 2. We're doing a 90 degrees clockwise rotation. And again, I'm just going to copy the pre-image coordinates from above. So C is at negative 5, 5, R is at negative 2, 3, and Q is at negative 5, 1. All right, so for my image coordinate, my rule says for 90 degrees clockwise, I need to take the opposite of the x coordinate and then switch to order. So I like to do this in 2 steps. Okay, so first I'm going to take the opposite of all of these, and let's see here, I can do this with a black pen if I go through and I just quickly take the opposite of all the x's. Okay, so I'm taking the opposite of all of these guys, and then I'm switching the order. So C prime, if I switch the order, it's going to be 5, 5. For R prime, if I switch the order, it'll be 3, 2. And for Q prime, if I switch the order, it will be 1, 5. So again, 90 degrees clockwise, that's one quadrant in this direction, the same direction that a clock goes. So I'm thinking that my final answer should end up here in quadrant 1. Double check my points. Everything is positive. So far, so good. All right, C prime is at 5, 5, which is up here. R prime is at 3, 2, 1, 2, 3, 1, 2. And Q prime is at 1, 5, which is 1, 5. There. Again, same shape. It's just been rotated around the origin. Okay, last example. I know this video is kind of long, but there's a lot to know here. This is the most difficult transformation of the 4. Start with our pre-image coordinates. Pre-image coordinates we can copy from above. X is 3, 3. B is 4, 3. Z is 4, 1. And we're going to use the rule for our image coordinates. Okay. If I'm doing a 90 degrees counterclockwise rotation, that means this triangle should end up one quadrant over here, so I'm thinking it's in quadrant 3. What do I know about quadrant 3? X is negative, Y is positive, so that should be what happens with all of my coordinates here. So the first step is this time we're taking the opposite of all of the Y coordinates. So this will become negative 3, and negative 1. And then I'm going to flip-flop the order. So X prime is going to be negative 3, 3. B prime is going to be negative 3, 4. And Z prime is going to be negative 1, 4. Plot the points. Negative 3, 3. Negative 3, 4. And negative 1, 4.